So we have learned two laws relating to refraction given by Snell. What are these laws? First law is the incident ray, refracted ray and the normal all will lie in the same plane. That means all this normal, refracted ray and this incident ray will lie in the same plane, and this plane is xy plane. It is not extended in z direction, so it is not in z direction, so it is only in xy direction. Now second law is the ratio of sin I to sin R is a constant, and this constant is called refractive index. The ratio of this angle, sine of this angle I and sine of this angle R is a constant which is called refractive index, and there are two numbers written 2 to 1. That means refractive index of the second medium with respect to first medium. So this is not only the refractive index of the second medium with respect to the first medium. So what is the meaning? So this equation is called Snell's law. We note that n21 is a characteristic of the pair of media. So what is this n21? This is the characteristic property of two media, the outer media and the media in which light is entering, and also depends on the wavelength of light. So this is very important. This n21 depends on these two mediums or these two medium 1 and medium 2, as well as wavelength of the light, but is independent of the angle of incident. So it is independent of this angle of incident but depend on these two mediums, medium 1 and medium 2. It is independent of this. So if we have to calculate this, what is the angle of this refraction? It is nothing but sin I upon n21. So this, in this way, if we know what is the refractive index of the material 2 with the material 1, then and we know the incidence angle, then we can tell this will be the refractive angle of refraction. Now let us see some of the cases. n21 is greater than 1. If we have such a medium which is denser, that means this n21 is greater than 1, then R is less than I. So this is the case shown above. So this is the case shown here. We can assume that this outer material is air and this material is glass. Then definitely the refractive index of glass in comparison of air is 1.5. Let us assume it is 1.5. It is greater than 1. Then here we can see this angle of incidence is much larger. This angle of refraction is smaller. In that case, R is less than I. That is, the refracted ray bends towards the normal. So this refractive ray has bent toward the normal. In such case, medium 2 is said to be optically denser or denser than the medium 1. On the other hand, suppose we have reverse, n21 is less than 1, then what happens? This R will be greater than I. The refracted ray bends away from the normal. So this will go away from the normal. We will learn how this will happen. This is the case when incident ray in a denser medium refracts into a rarer medium. So what is the meaning of this? So meaning of this is, suppose we have a glass slab. We have this glass slab, and from the property of glass and air we know that glass is denser than air. So this is not the normal density but optical density. This is the optical density, optically denser. So we know glass is optically denser. So let us draw the normal. So this is our normal. So suppose some light is coming at some incident angle I. This is I. So this was its usual path in which it was going. Since this material is denser, so this is the normal. So it will bend towards the normal. It will bend toward the normal, and this angle of refraction is less than angle of incidence. Now if this medium is denser, then again it is coming out in air. This will come again out in air. So this is denser. So let me write denser, and this medium is rarer. Let me write R. Again it is coming back to air. That means a rare medium. So this will move away from the normal. This will bends away from the normal. So this will again bends away from the normal. So this was the normal at this point, and this was the angle on which it was going. Now it moves away. So let us draw this diagram once again to understand it completely. So we have this glass slab. Let me make this much thicker so you can see. So this is the normal. This is air. This is glass. This is denser medium, this is rarer medium. This is again air, and this is a rare medium. So a beam of light is coming. Let us say this angle is I. If it is entering into glass, then what happened? This is the normal. So it was its usual path on which it was going. So it will bend towards the normal in denser medium. So now it has bent. So this angle has been reduced. This was previously I, now it is R. It has been reduced. Now it was going on this direction. Since this medium is denser, this medium is rarer, again we draw a normal. So in case the light beam is coming from denser to rarer medium, it will move away from the normal. So in that case what we do, we move it from the normal. So what we can see, initially it was coming at an angle I, then it bends inward, then again it moves away from the normal, and this angle, if this medium 1 and medium, this side medium is also 1, again this angle becomes again I. So in between it is reduced, then again it becomes I. So whole picture is that I reduced, then same. When it enters into rarer medium, then it increases. Denser medium reduces. This was the original. So if this is the original direction and this is the interface, in denser medium bends towards this side, in rarer medium bends towards this side. This is rare, this is denser, this is original. So if with this simple figure we can understand this, the refraction. If this is the interface, this was the light's original direction of the light. So what we do, we on the interface we draw a normal. If the material or the medium here, so this was the medium 1, this was the medium 2. If the medium 2 is denser, then this side, this is the denser, this was the original. If it is rare, then it goes away from the normal. Rare, away from the normal, denser, towards the normal. So these are the properties. Now we have to note this optical density should not be confused with the mass density. So we should not consider, because mass density of glass is very high. So optical density should not be confused with the mass density, which is mass per unit volume. it is possible that mass density of an optically denser medium may be less than that of optically rarer medium. So, it is possible that an optically, suppose this material too is optically denser. So, light was initially this direction. So, light is bending towards this direction, but this rho 2 and this is rho 1. So, they are saying this rho 2 may be less than rho 1. So, optical density is not the mass density. Optical density is the ratio of speed of light in two media. So, suppose if the speed of light in this is V1 and this is V2, then it is the ratio of speed of light in these two media. For example, turpentine and water, mass density of turpentine is less than that of water, but optical density is higher. So, we should not confuse mass density with the optical density. Optical density of turpentine, turpentine is an oil. So, turpentine is less than water, but optical density is higher than that of water.